It's time for networking. Alright, so I'm going to show you real quick how to match on additional information in an HTTP header. So specifically we're going to pinpoint the URI path information and the parameter information. And again, we are going to use my favorite website, http-req-headers.com. Yay. Alright, here we go. So first thing I'm going to do here, I'm going to make sure Wireshark is up and running, and I'm filtering on the IP address for that website. Awesome. All right, next thing I'm going to do is I'm going to browse to the website. So I'm going to bring up Chrome, because I need this to be decrypted, and you need to use Chrome in order to offload the symmetric session key and get it into Wireshark so you can decrypt from a previous video. Thank you very much. All right, so let me browse to this website. I'm going to take a look and make sure that I am decrypting, because if I don't decrypt, the firewall is not going to pick up on this information, so it's going to be completely useless. But we are decrypting. Palo.lab.com. Excellent. All right, so I'm going to go ahead and leave this up. Take a look at the PCAP. See traffic coming through, see my initial get for the website. And what I'm going to start matching on in this flow is one of these PNG files. So I'm going to match on 7. Actually, I'm going to match on 7 and 9, because I'm going to do 2 different techniques here to make this happen. Alright, so if I drill down into this header, this get header, and I look at the path, and there's the path, so the URI piece of it is check.png, question mark starts is basically a query, and lets you know that you're going to start checking parameter information, which is a string of digits here and an _7. So each one of these pictures ends in an underscore and a number. However, the number in front of the underscore seems to change, and I'm not sure exactly if there is a specific boundary on which it doesn't change, but so far what I've seen is 157928 stays the same. And the last, 7 digits is changing. So I'm going to leave this running. Let's see here, just to match on this so I can point this out to you. On 7, we got, let's see, get back 28, so 49, 493, 43, 18. 493, 43, 18. I don't know why I'm trying to remember that. That's 493, 43, 18. Okay, anyway. All right, so I've ran this again, right? So there's 49, 34, 318. That's what I was trying to say, and I didn't remember it. But anyway, cool. So what I'm going to do is I'm going to match on this path value down here. I'm going to filter it. Give me a filter. Thank you very much. There we go. All right. And I am going to take all of this out, except for the -7 or the _7, and I'm going to change the equal to contains. Make sure my fingers are lined up. Okay, awesome. All right, so there's that, and we're also matching on this 70717270. I'll show you how to get around that, so it's not a problem. So we started out with this 157928, 49, 34, 318, 49, 34, 318. All right, and then we come down to this next one. After 28, it's 50, 48, 94, 79. So that's changing, right? I don't know that once, if this gets up, let's say this 50 increments up again, or the 5 increments up to a 9 and then goes to a 0, is this going to change this from 28 to 29? I don't know. So I don't want to base my match off of this number here. I only want the _7. And then the rest of the information is going to identify it, right? So this is going to be a transaction match. And the way that I'm going to do this is going to be under this one packet get request matching on the authority, and then coming down and matching on the URI path, and then matching on this _7, followed up by trailing hexadecimal 00. Right? And the reason I'm going to do that is so I don't want to match on another ASCII character after the 7, a 0 through 9, right? And so the easiest way to do that is take a look and see, well, what else follows under this header, or what comes after that information, right? And so if you look down here, like if I follow through the ASCII representation over here and I get on to 7, that's 37. So 37 in hexadecimal represents 7 in ASCII. All right, what's the next character? 0. Followed up with zeros. All I need to follow up with is a hexadecimal 00 that does not represent an ASCII character whatsoever. It's just blank data. There's nothing there. I mean, it's like a placeholder, I suppose. And, you know, when you look at the ASCII table and you see the different values for printable ASCII characters, it doesn't start until, I want to say, like 30, maybe 27. I don't know. Anyway, there's a lot of control characters as well. So when you run into situations like that, you have to match on the hexadecimal information versus trying to use an ASCII character. So just keep that in mind. All right. So we're going to go build this thing. So I got this up, got my website up. I'm going to go ahead and leave it. I'm going to bring up the Palo. And I'm going to go ahead and make another signature. As soon as it comes up, I'm going to call this http-vs. Actually, let's do dash png. And this is going to be 7. All right. I don't care about this. So I'm just going to fill it in because it's yellow and I have to fill it in or it won't let me progress. And I definitely want to progress and learn how to speak too. So TCP 443. Awesome. Good enough for me. I'm going to add this signature in. Now this first one I'm going to do PNG check, and it's going to be a transaction. One simple transaction. And I'm going to add in one signature. And it's going to be http-req-headers. I'm going to match on www 0 or 1 times http-vs https.com. All right. I'm going to make this easy, and I'm going to dot star it so this can be any string of any number of characters, any character. It doesn't matter. It's going to match on it. All right. Cool. Next thing I'm going to match on is going to be this / check dot, and I need to cancel the dot out, PNG. Awesome. And that gives me a nice full 8 bytes of matching data. I already had a bunch over here anyway, so it doesn't matter. But remember, in order for a signature to be successful, you need 7 bytes of contiguous data to match with no variables, no regex, nothing. All right. And once you have that, then you're golden. You can do all kinds of stuff, unless you do a byte count range using the curly brackets. Right. For some reason, you need 7 bytes on either side to make that happen. So, anyway. All right, cool. So that's good. I'm going to put another dot star in to match that length of digits that comes in the parameter section, _7, right? And then I am going to put in my hex 00. All right. And that should do it. So let's go ahead and apply this. See if we get any errors. Should be good to go. All right, cool. So that looks good. I'm going to apply this. Actually, you know what? Before I do that, save some time. Let's make another one. I love making signatures. All right, let's do http-vs -png -9. Let's do 9. Sounds like fun. All right, again, don't care. Cool. All right. Dun, 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 dun. Looks good. Going to port. Add in. Come on. TCP 443. I have a lot of things going on this firewall, so the management interface is kind of sputtery and slow and all that fun stuff. All right. So that's going to be another transaction. This is going to be PNG fun transaction type. Now I'm going to have to add in multiple conditions here. So I'm going to pattern match first on HTTP host header. It's going to be the www https com. Good. Everything looks great. I love it. All right. I'm going to put that in there. All right. I'm going to make a and condition off of this because I'm following it right down the line. There's no question here what I want to match. HTTP. It comes up. I'm doing a request URI path. It's my next one, right? It's going to be a / check dot p. Actually, cancel out the dot. PNG, right? Simple. I could put a qualifier in, but I'm not going to. So it's actually a get request, right? But I'm just going to leave it the way it is. It's fine. I don't care. All right, and then last condition, right? Now this is where things get kind of interesting. It's going to be an and condition. It's going to be parameter, right? I'm looking for parameter. The problem with using parameter is that it only matches on the parameter. So that string of digits that's constantly changing and an underscore and a digit that doesn't change. Well, that doesn't help me at all. Actually, it's pretty awful. If I look back through the data, I might be able to get around this. Well, let's see. What do I got here before I go on to the next? User agents next. So I have 4 bytes here that I can add in. 4, 5, 6 does not give me enough, right? It's not going to work. So I have to do something different here. So I'm going to change this. In this case, I'm going to change it to http request headers, right? And I'm going to go ahead and match on that check. Come on. PNG dot star underscore 9. All right. And so that gives me my 7 bytes of contiguous data right here that I'm matching on. And then I'm able to throw in that underscore 9 there as well to match. And then I want to make sure I close it off because I don't want something else. I don't want to, I'm sure there's a 9D or something in there. So let me go ahead and put in my hex delimiter 00. Close that out. Looks good. All right. All right, and this is an ordered condition match, but what I am doing is I'm looking in specific contexts, right? So host header, URI path, and then down here I had to revert back to just the entire list of headers, right? Which is what I did in the first signature. I just matched completely on this, and it captured everything in a request header, in the request header fields for HTTP, right? So I'm going to say okay, make sure everything looks good. No errors. I should have 2 brand new flashy signatures to match on PNG 7 and PNG 9. All right, I'm going to commit this and I will be back. Okay, so the commit is done. I might have made a mistake with the PNG 9, so we'll find out in a second. So let me go ahead and go to monitor. And so you can see where I did test earlier. I was at 132. I had this in earlier because I was playing around with it. And it worked. And I denied it. And that was interesting because it just stopped loading the page completely. But anyway, cool. Now I have a 10-second refresh. I'm matching on HTTP VS-PNG-7. So let's take a look and see what happens here. So I'm going to come up here with this website. I'm going to do a refresh. All right. And my user agent timed out. I really I need to go and adjust that. Anyway, it's all right. It's just a little bit of frustration, that's all. All right. So we come back, reload. Certificate still issued. Yeah, everything's good. I didn't change anything, so I'm gonna leave that there. Come back here. Let this thing refresh, and there it is. All right, so we got a hit. It's kind of cool too. If I go into URL filtering, oh, I already have it. Cool. You can see it right here is the flow. And you can see exactly what it matched on. You can see that _7, right? So cool. So it's doing what it's supposed to. It's exactly what I want. All right, now we're going to change this. I'm going to go back to traffic. And I'm going to change this to 9. All right. And we got a hit on 9. Look at that. It was already there. It was there all along. It was working perfectly. So my question about that, whenever I was thinking about how I built out this signature and I was looking at it, and I'll just point this out to you, but we know for sure that it's fine for whatever reason. When I look at the signature that I built, right? So it's ordered condition, right? So I matched on URI path for check.png, right? But then I began exactly at the same point down here in an ordered condition with check.png. I just went a little further, right? So my thought was that I might have to adjust this to match on _9, maybe do a range, and then match on the user agent field, right? But that didn't have to happen. I match successfully. So that's good to know. So looking at this signature and looking at the traffic, if I go in and I block this, and I can actually change this. Let me do this so we can just see everything all at once. Copy, type in or, paste, bracketize. All right, and so we can see both of them. Actually, I didn't change the digits, so that's kind of dumb. There we go. And it comes back. Now we got both of them in there, right? And if I take this and copy it, and I like doing this, looking at URL filtering, because it just gives you, a complete look at what you matched on, because we are matching on HTTP information, and it's based on a URL built out from a URI path and a query or a parameter, right? And so we can see the _9, we can see the _7, we're good to go. So that is how you match on specific information in an HTTP request, and this was a specific transaction as well. I want to point that out. Before, when I was making signatures in the other videos, they were session-based, right? This is a transaction-based. Everything matches in that one request, and it comes through, as far as the header is concerned, in one packet, right? Now, whatever is taking place in that, if you were posting something, then you're going to be shooting some data across, and usually you'll see a request header packet that comes across, and then it'll follow up with data, and depending on how big the data is, you'll have multiple packets of data that get sent through and get chopped up based on the MTU, right? So that's something else to consider as well. So anyway, that's how you do it. Hope that you got something out of this, and we'll move on to some more interesting stuff in the coming videos. Thank you.